Functions. A function is an equation that transforms one number into another number. While this sounds complicated and vague, it essentially just means that when you have an equation, plugging in different values for the variables will change the value of the equation. For example, y equals x squared is a function. The conventional way of writing this as a function is f of x equals x squared. All f of x means is the value of y for a given value of x. Think of f of x as simply a different way of writing y. In fact, you could express this as f of x equals y. F is not the only variable you'll see to express functions. F, g, and h are all typical variables that will be used. Let's take a look at an example. If g of x equals x squared plus 2, what is the value of g of 2? This looks much more complicated than it actually is. All g of 2 means is plug 2 in for x and complete the operation. So g of 2 equals 2 squared plus 2. That gives us 4 plus 2, which is 6. Easy enough. So what would the value of h of 5 be when h of x equals 2x squared plus 5x minus 10? As we discussed, h of 5 simply indicates that you should plug in 5 for all of the values of x in the equation. So let's plug 5 in, which leaves us with 2 times 5 squared plus 5 times 5 minus 10. Think back to PEMDAS to execute this equation. 5 squared is 25, so we have 2 times 25 plus 5 times 5 minus 10. That's 50 plus 25 minus 10, which is 75 minus 10. And that's 65. There's your answer. Let's take a look at another example. If f of x equals x squared plus 4x for all values of x, and f of a equals negative 4, what is the value of a? Again, this problem looks complicated with two functions, but it's really just a matter of substitution. We know that f of x equals x squared plus 4x, and we know that f of a equals negative 4. We'll set the equations to equal each other, so we have x squared plus 4x equals negative 4. Add 4 to both sides, and we have x squared plus 4x plus 4 equals 0. Think back to factoring, and we know that x squared plus 4x plus 4 simplifies to x plus 2 times x plus 2 equals 0, which when we set x plus 2 equals 0 and subtract 2 from each side, that gives us x equals negative 2. And that's our answer. Let's take a look at what some function questions will look like on the GRE. Define a triangle B to be a squared. You may be wondering how defined functions differ from the f of x functions we just covered. They don't. They are the same concept. The function could be rewritten as f of a and b. The purpose of defined functions is to see how well you can adapt to unusual structures. Once you realize that defined functions are evaluated and manipulated just as regular functions, they become much less daunting. For this particular question, it is important to note that only a is transferred into the function. So anything in the b place doesn't affect the function. Therefore, column A and column B would both be z squared. Now, let's try a practice problem. Define x squared y by the equation x squared y equals xy minus y. Then 2 squared 3 equals... For this problem, all you have to do is plug in the values to the corresponding spots. So 2 would replace the x, and 3 would replace the y's. Solve using order of operations, and you will get 3. Let's try another problem. For all real numbers x, y, and z, the line x, y, z equals x minus y times z. Which is greater, column A or column B? By plugging the numbers into the function, that will give you 0 minus 1 times a, and 1 minus a times 0. No matter what a equals, column B will always equal 0, because it is multiplying 0 by every other number in the function. What about column A? A could be 0 and be equal to column B, but it could also be a positive number or a negative number, which would make the value greater or less than column B. Therefore, we cannot determine which is greater with the information given.